Okay, let's get into this. You know when you're using a website and it just stalls. Things get sluggish, unresponsive,
Huh.
just janky. We've all felt that.
Oh, yeah, that feeling. And you wonder, why does this site feel fast, but that one just drags?
Exactly. And it obviously comes down to these things called performance bottlenecks.
Right. Bottlenecks. Think of it like a traffic jam inside the web application.
Yeah.
Something's blocking the flow, stopping things from running smoothly.
And understanding these jams, these common problems,
Yeah.
is really step one if you want to write faster code, or even just understand why some web experiences are better than others. It's, pretty essential stuff.
Definitely. So a really big one, maybe the most obvious cause of that jankiness, is messing with the DOM too much.
The DOM. That's the document object model, right?
Yeah.
The browser's map of the web page.
Exactly. And when your JavaScript is constantly adding elements, removing them, changing styles, especially really quickly, well, that can get costly.
Costly how? Like, changing one small thing can mess up the whole screen layout.
Uh-huh. Particularly if you change something and then ask the browser for layout info, like how wide is this element now, offset width or offset height. Doing that forces the browser to recalculate everything. It's called a reflow. It figures out where everything needs to go, and then it has to repaint the screen, parts of it.
And that takes time. It blocks things.
It completely blocks the main thread. So while the browser's busy recalculating and redrawing, it can't respond to you clicking or scrolling, hence jank.
Okay, so blocking the main thread, that seems important, which kind of leads into the next point, right?
Yeah.
JavaScript itself taking too long to run.
Precisely. Sometimes the script just has a lot of heavy lifting to do. Maybe it's doing some really complex math or churning through a huge pile of data.
Or maybe just stuck in a bad loop.
That too. Whatever the reason, if a script runs for too long without pausing, that main thread is, again, totally occupied.
So if the thread's busy with your code, you can't handle clicks, can't update the screen.
Yeah.
Nothing.
It's completely blocked. This is a huge factor in how quickly a page feels interactive, that time to interactive metric, or TTI. The page might look loaded, but if you click and nothing happens, well, that's probably long-running JavaScript, frozen screens.
Right. Okay, so that's stuff happening in the browser. But sometimes the problem starts even earlier, like getting the data to the browser. Network issues.
Absolutely fundamental. Performance starts the moment you request the page. How fast can the browser download all the necessary files? The HTML, the CSS, the JavaScript, the images.
And big files obviously take longer, especially big images or like huge JavaScript libraries.
For sure. File size is a major factor, especially on mobile or slower connections. But it's not just size.
What else?
The sheer number of requests. If your page needs to fetch, say, 50 tiny JavaScript files and 30 small images separately.
Each one of those requests adds a little bit of delay.
Exactly. There's overhead for each connection, each request and response. Lots of small requests can sometimes be worse than one slightly larger one. It all adds up and slows down that initial load, making the user wait.
Makes sense. Okay, moving on to something maybe a bit sneakier. Memory leaks.
Ah, yes. The silent performance killer. These often creep up on you, especially in single-page applications that people keep open for a long time.
So what is a memory leak exactly?
It's when your code uses some memory, maybe to store data, or reference an element on the page, but then forgets to release that memory when it's done with it.
So the browser just holds on to this useless data forever.
Pretty much. It accumulates. Common causes are things like removing an element from the page but keeping a variable pointing to it somewhere in your JavaScript, or setting up timers or event listeners and not cleaning them up when they're no longer needed.
And the effect isn't usually a sudden crash, but more like the app just gets heavier and slower over time.
That's typically it. It gets sluggish. The browser has to work harder to manage the growing memory usage, garbage collection runs more often, and everything just feels bogged down. Eventually, yeah, it might crash the tab, but usually it's just slow degradation.
Okay, one last major area, how we actually style things and how the browser draws them. CSS and rendering.
Yeah, this is critical too. Not all CSS properties are created equal when it comes to performance. Changing some properties is much more expensive for the browser than changing others.
Which ones are the expensive ones?
Generally, properties that affect the element's size or position its geometry. Think with height, margin, padding, top left. Changing these often forces that expensive reflow and repaint cycle we talked about earlier.
Right. But some properties are cheaper, like transform or opacity.
Exactly. Browsers are often optimized to handle changes to transform, like moving or scaling, and opacity, fading in or out, much more efficiently, often without needing a full reflow or repaint. They can sometimes handle these changes just on the graphics card, which is much faster.
So if you're animating things frequently using those expensive layout properties,
hmm
you're going to get choppy animations and jank.
You definitely risk it. Even if your JavaScript is super fast, expensive CSS updates can still bottleneck rendering performance and make things feel stuttery.
Wow. Okay, so to recap the big hitters, we've got costly DOM changes forcing recalculations, long JavaScript tasks blocking user interaction, slow network speeds or too many requests, memory leaks making things heavy, and then expensive CSS causing rendering lag.
That's a pretty good summary of the common culprits, yeah. Understanding these is the first step. The next step is figuring out which one is causing your specific problem.
Totally. Knowing what can go wrong is one thing. The real skill, and maybe the interesting part, is learning how to dig in, use the browser's developer tools to find the actual bottleneck in your own code, and then apply the right fix.
That's where the optimization work really happens.
So thinking about these 5 areas, DOM, JS execution, network, memory, CSS rendering, which one resonates most with you right now? Maybe something you've struggled with in your own projects, or perhaps a website you use that just feels off, worth thinking about.